Hi guys, in today's video we're going to be learning how to calculate the area of a compound shape. Now before you do that you're going to need some prior knowledge. So if you haven't yet watched the video on how to calculate the area of a rectangle or the video on how to calculate the area of a triangle, go and watch them first before progressing to this one. However, if you watched them already, let's get started. So, a compound shape, first of all, is simply a shape that is made up of two or more smaller shapes. So we have this L-shaped pattern here. What's that really made up of? Well, it's made up of a couple of rectangles that have been joined together. So if I want to calculate the area of this whole shape here, all I'm going to do is I'm going to calculate the area of the two individual rectangles that make up that shape. Now, it's up to me how I view those rectangles. I could easily view it this way and have one rectangle here and one rectangle here. However, I could chunk it up this way and have a larger rectangle here and a smaller rectangle there. So there's different ways that you can view it. And in each situation I'm obviously only going to teach one of the ways of chunking it up, but you might choose to do it a different way, and that's equally as valid as long as you arrive at the correct answer. So, in this case here, I'm going to view this as two rectangles here. So I'm going to go a blue rectangle here, and we'll go an orange rectangle here. Once I have chunked up this shape into its two composite shapes, I can then start working out the area by simply counting the length of the edges and multiplying them together. So all area is multiplication. Now, in terms of laying it out, what I would do is I would label each one of these shapes. I'm going to call this one A1, and I'm going to call this one A2. So in terms of my working, I'm going to do two separate sums and then add them together. So we'll start off with A1. A1, across its horizontal edge, so going side to side, it's 3. So A1 equals 3 times up its vertical edge is 1, 2, 3, 4, 5, 6. So it's going to be 3 times 6, which is 18. So it's 18, and if we're pretending these are each centimetre boxes, we'd say it was 18 centimetres squared. Okay, what about A2 then? So A2, well, it's 1, 2, 3, 4, 5, 6 across its horizontal edge, but it's only 2 along its vertical edge. So 6 times 2 is 12 centimetres squared. Now at that point, I've calculated the two areas of the two shapes that make up this compound shape. Now all I need to do is add them together. Now I could do that as a separate chimney sum and then double underline my answer there, but you know what? I've already got the numbers here. They're already lined up with the units lined up and the tens lined up. So I'm just going to add my chimney sum, or my formal addition sum, right here. So I've got 8 plus 2, well that's 10. I'll do my working in a different colour. So I'm putting my 0 there, and the extra 10 is going to the next column up there. So now we have 1 plus 1 plus 1 makes 30. So the total area of this shape here is 30 centimetres squared. And were I to count all the boxes individually, we would eventually get to the number 30. So there are 30 square centimetres in that compound shape. So you've got two other compound shapes here that I'm just going to leave up for you to try. So if you want to pause the video now and give it a shot, now's the time to do that. And I'm going to put up the answers in the next 5 or so seconds. So our answers then for this orange compound shape up here, the total area was 22 centimetres squared, and for this one down here, it's 69 centimetres squared. So getting ever so slightly more complicated now, we now have a more detailed compound shape made up of more rectangles. Now again, I can chunk these up several ways. I could chunk them up this way here, I could chunk them up this way there, or there's other ways that I could chunk it up as well. But you know what? I've gone for this solution here. So let's get cracking with this. So what do I see there? I see 3 rectangles. So we'll call this area 1, we'll call this area 2, and I'll call this area 3. So same process as before. I'm just going to calculate the area of each one of these smaller subsections and then add them together. So for area 1, we've got 1, 2, 3 times 1, 2, 3, 4, 5. 3 times 5 is 15. Okay, for area 2, 3 times 5 again, same thing. Area 2 equals 3 times 5, which equals 15. And area 3, slightly more complicated, or just slightly bigger. 1, 2, 3, 4, 5, 6, 7, 8 times 3, which is 24. So lastly, all my columns are lined up, the units are in line, the tens are in line. So now I just add them together. 5 plus 5 plus 4 is 14. The 4 goes down in the units, and the 10 goes up into the tens column. We have 1 plus 1 plus 2 plus 1, which is 5. So we now have 54 centimeters squared. Now, like before, there's 2 other examples on the side here. I'm going to leave them up for a little while. Pause the video now if you want to try them yourself, and I'll reveal the answer in a couple of seconds. So our answers then, for this red one up here, we've got 36 centimeters squared, and for this one down here, we have 49 centimeters squared. Now, of course, your working might look slightly different to mine because you might have chunked these shapes up in different ways. But really, it shouldn't matter how you chunk them up. It's just a matter of calculating the area for each section correctly, and then no matter what way you chunk it up, you should arrive at the correct answer. Now, a slightly different skill here. We have an overall shape, but in this case we're being asked to remove a section of the area. So in order to do this, if we're removing something, you might be thinking, well, what operation is that? What process is that? And obviously it's going to be subtraction. So in this case, I've got this large area here, which we'll call area 1. But I've also got this smaller section in here, which we'll call area 2, and that's the bit that I'm going to be removing. So I'm taking away area 2. So to work out this, I'm going to work out the 2 separate areas. So area 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9 from side to side, horizontally. And it's 6 down the side, which gives it a total area of 54 square centimeters. However, this area 2 here, somewhat smaller, is 3 along the top and 2 along the edge, giving it a total area of 6 centimeters squared. However, in this case, we're not going to be adding them together, we're going to be subtracting the small one from the big one. So it's going to be 54 take away 6. So 4 take away 6 we can't do, so we're going to have to exchange. We borrow a 10 from the tens column and move it down to the units column. So we temporarily have 14 here. 14 take away 6 is 8. 4 take away 0 is 4. So we have 48 centimeters squared in this shape here. Now, with these other 2, it's very much a similar process. We calculate the total area, and we're going to be subtracting this black section here. However, in this case, we have a compound shape, but with a missing area here that we're going to have to subtract. So we're going to have to chunk it up into its individual rectangles and then subtract the missing area. So I'm going to put the answers to those ones up in just a second. Okay, so for this one here, we have area 1 take away area 2, so 50 take away 8, which gives us 42 centimeters squared. For this one here, what I've done is I've calculated area 1, which is 21, area 2, which would have been 24, and together that makes 45. However, I've then subtracted area 3, which is 4 square centimeters, giving us a total area of 41 centimeters squared. So in these final examples, we don't just have compound shapes that are made up of rectangles, we have compound shapes that are made up of rectangles and triangles. So we're going to have to be using our understanding of triangles to solve these problems. So working with this first one here, again we're going to chunk it up into familiar areas, into familiar shapes. And the easiest way to do that in this case is just going to be a rectangle here, which we'll call area 1, and a triangle here, which we'll call area 2. So to work this out then, we've got area 1, which is 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, so it's actually a square, which is 25. But then we've got area 2, which is a triangle. Now, triangles are just half rectangles. So as long as we basically work it out as if it was a rectangle and then half it, we'll get the correct answer. So we've got the base of the rectangle, which is 1, 2, 3, 4, 5. So area 2 is going to be 5 times, from bottom to top, up and down, it is 1, 2. So 5 times 2 is 10, but then we're going to have to also, I've run out of space a little bit here, I'm also going to have to divide it by 2. So 5 times 2 is 10, divided by 2 is 5. So our total area there, 5 plus 5, I'll change colour, 5 plus 5 is 10, 2 plus 1 is 3. So it's going to be 30 centimeters squared. For the sake of repetition, I'm also going to demonstrate this orange one up here. So we've got area 1 and area 2 here. So area 1 is 4 along the top and 3 along the side, which is 12 centimeters squared. Area 2 along the bottom of the triangle, so I'm kind of having to imagine the triangle on its side here, but we've got 1, 2, 3, so a base of 3, but then the height of the triangle is 2. So 3 times 2 is 6, however, I then need to divide it by 2. So it's actually just 3. So our total area there, 2 plus 3 is 5, 1 plus 0 is 1, so it's 15 centimeters squared. So there's two other examples here, slightly more complicated. This one just consists of 2 triangles, whereas this one, it consists of 2 triangles plus a variety of rectangles as well. So I'm going to put the answers to that up in just a second. So just to save space, I'm working these ones out separately so you can follow my working. But for this red one down here, our total area is 19 centimeters squared. And for this final one here, our total area is 55 centimeters squared. So that's compound shapes. All we do is we chunk it up into manageable areas that we're familiar with how to calculate the area of, and then we just add together each of the individual sections to get a total answer. Cheers, guys!